Hello everyone. If someone wants to give me a shout out when you join, I'd like to make sure my volume is okay and that you can hear me. Earlier today I figured I wanted to do a live stream, but I wasn't sure what time, so I apologize for not giving anybody advance notice here. I decided to just throw it up and see if we get any watchers. Hello, hello. Give me a shout out in the chat when you get connected. Hi, Edwin. All right, cool. Number one what, Commodore? Number one to post something? Or number one as in you like the Harmony Turbines project and it's number one in your heart? Well, you weren't the first to post because Edwin came up first saying hello and that I was coming through loud and clear. So you were number two, Commodore. That's okay. We need number twos just as much as we need number ones. So Edwin gets the prize, the coveted honor of being number one tonight, first to post. Again, sorry that I sprung this on everyone last minute. I was going to do a planned live stream for tonight, but earlier today things were so crazy that I didn't know if I'd be able to stick to the schedule, so I figured, you know what? I'm just going to fly by the seat of my pants. We're getting millions and millions of users and hits and subscribers every week, so I figured, there's going to be a couple tens of thousands of people that join, right? Maybe that's my alternate reality. Terry, hello. All right, well, I'm going to get started. I wanted to do a live stream tonight. My intent is not to go talking for an hour and a half, but who knows? You know me. I get to chattering and things get out of hand and then it gets crazy. So I wanted to share the first glimpses of the new outdoor prototype development. I've got, I'll give a little recap for those of you who didn't get a chance to watch my other live stream the other night. I have already submitted my request to the south, to our township here in the area where I live, and asked them if it would be okay to put this turbine up, a permanent outdoor prototype, in my front yard. The reason I'm asking for the front is because we get northwesterly wind many, many, many more days out of the year than we get any other wind. So to capture that northwesterly wind, it would have to be in the front yard. I don't think they like that quite as much as me asking for it in, the side or backyard, but they said they are going to consider it because of the wind issue. So I submitted my paperwork to them last week. They are going over it now. I've already got the new Harmony Turbines LLC paperwork into the state. So the state now has all of my stuff. My EIN, employer identification number, has been filed for Harmony Turbines. So we've got the state paperwork, the federal paperwork, and the township paperwork to be putting up a turbine. I've also begun work on StartEngine.com. StartEngine.com is who I believe I'm going to go with for equity crowdfunding. And if you don't know what equity crowdfunding is, I would encourage you to take a look at StartEngine.com's website. They can help you understand it. It's kind of like Kickstarter or Indiegogo, but instead of giving out items and selling items, taking pre-orders for those items and then selling them to people, you're actually selling a stake in the company. So if you guys would be endorsing and backing up Harmony Turbines, you'd actually be in for a piece of the pie, or have some skin in the game, whatever the phrase is that you use. You would be investing in the company. Now, early on, that would be a seed investment, so it's done with a type of product that's called, let me pull it over here. I closed that one thing. Oh, give me one sec. They're convertible notes. Sorry about that. I'm just learning all this stuff. Their website's great. It helps walk you through things, helps actually bring you live with your product and with your company. So you would be doing the raising of the equity round of funds through that mechanism. So convertible notes are how you do your first round of seed funding with something like this, what Harmony Turbines is going to have. So tonight, the live stream, I thought, you know what? I've got all of the paperwork in for the federal, for the state, for the township, and for startengine.com. I've already begun that paperwork, but I can't finish it until I get the stuff back from the state and everything. So, hello, Mark. How are you tonight? Michael, hello. Commodore, Terry, and Edwin. So now that I have all those things in the works, of course, I'm sitting here thinking, well, I better get started on the design because the township's going to want to know how it's going to look and what's going to be involved. So I began the other night, 2 nights ago. I had when I did my live stream 2 or 3 nights ago, I think it was just 2 nights ago, I was showing the very beginning of what I thought would be that design session, but I didn't get more than 5 minutes of design, and the rest of it I was talking. So I've been working pretty hard, and I've got everything finished to a point where I'm happy enough to show it to you guys. So here is the frame. Ooh, it's too bad I can't hear you guys. You guys are probably like cheering and clapping. No. Anyway, it's just a frame. The support beams here are probably 6x6 steel. I have them support pull diameter of 6. This will be like 2x2 square stock holding up those 2 pieces in the middle, and I will probably need some diagonal supports in here, maybe not real big, but a little bit of diagonal supports to help hold that metal one, or hold the lower central support up. So that is the frame, and then you're really going to like this. My scoop pairs, which I was showing when I started the live stream, these are the brand new scoop pairs. Terry, I might be tapping you to help me do these because I'm looking at maybe making them out of aluminum, since aluminum doesn't rust. I understand that there's a little bit of problem with corrosion if I get it up against other metals like steel, so I'll need your advice and your help there when it comes to dissimilar metals plugging into this. So these are the new scoops. They are 3 feet, so they're 50% larger than before. So they're 3 feet tip to tip. Let me hide this top piece, and I'll show you guys. So they're 3 feet. If I close it up, it's easier to envision in your mind. So tip to tip, they're 3 feet. Thank you, Mark. Thank you, Terry. They're 18 inches tall, so 1.5 feet high, 3 feet in diameter, and they are beautiful. There's also a new feature that I've added here. You'll see that front scoop has what I'm calling a wind barrier or wind break. What did I call it here? Front guard, I just called it. I called it a front guard, and that guard on there is movable. So I have it right now. If we're looking at the scoop pair, let me hide. I'm going to hide the one so I can show it to you better. Isn't CAD amazing? I freaking love CAD. I learned how to do it just, 2 years ago, maybe 2.5 years ago I started. Could have even been 3 years ago, but I was horrible at it. I played a little bit with SolidWorks, but since I got Onshape, Onshape.com is amazing. And it lets you do so many cool things with it. This wind guard that I have in the front guard, what did I call it? Now I can't even remember. I just said it a second ago. I am so bad. I just called it a front guard. It's like a football player. This thing, I have it on parameters, so I can move it around at will. So I can, right now I have the front guard starting degree at 1, so that means it's 1 degree off of the edge of this gear, and I have it the other side, if I had it set to 1 degree as well, the ending degree, then this guard would go all the way over. So right now, like if I would set this at 1 degree, the front guard would fill that entire front space. Thank you, Terry. So see how that front guard now, by me changing that one parameter, has just filled that entire front space instead of just 90 degrees. But if I undo that, I have it only filling half. So the cool thing about this, by parameterizing things, I can play with this guard. I could say 20 and 90, and then it would make that front guard just be that little bit. It would start 20 degrees off of the edge of the gear over here, and I have it ending 90 degrees off the edge of the gear over there. So I can move this guard around wherever I want. My intent was to play with it visually, and then maybe one day when one of you guys who's really good with computational fluid dynamics, CFD, is able to help me out, I'd love to do some CFD on this, and we can find out where the best position, how big to make that front guard, where, what angle to put it at. I do think we need one in, so right now my best guess was about 90 degrees, starting at the edge of the gear to there. And the reason I did that, let me unhide all the instances here, is because as it spins, if we imagine ourselves being the wind blowing straight in here, as it's spinning, we get too big of a gap if we don't have some kind of a guard in there. So the pole is going to be in here now, so you're not seeing the pole. Actually, let's move over to, oh my, get ready for it, guys. Here it comes. Woohoo! Look at that. Oh my goodness. That's the full scoop array. And what I was playing with here is just what looks good for that front guard. Oops, that won't work. So if I animate this right now, I was trying to figure out what optimal angle to have that, how big to make that front guard, but I need to fill in that gap a little bit when that front guard's in there. And see here, harmony spinning, that would be like an incredibly slow, like half-mile-an-hour wind or something. Nah, maybe that would be like 1 mile to 1.5 mile an hour wind. But if I zoom in on that, you can see that guard is helping to funnel the wind around there correctly. So I'll try not to rotate it too much and make people seasick here. But computational fluid dynamics or real true field testing is going to be the only way to determine what my optimal setting is for that front guard, where to put it, how to position it optimally. Maybe it needs to be back a little bit, maybe 20 degrees off of the one side of the gear, or coming closer to the other side. Who knows? But I've got the easy parameters in there. In fact, in the field, what I could do is just put some screw holes in the back of the gears and then have that guard actually movable so that I could replace it and put in different guards once we do computational fluid dynamics on it, and we could see through CFD what appears to be the best placement for that guard. But I do think we're going to need one in there. So this is how it looks. Let's show you like more of a top view there. Pretty, actually really freaking cool. Straight down on top, that's what it would look like. And right now, I've got it, if I would freeze this main shaft, and let's open these scoops up. So now they're open 100%. Be nice if this remembered your last animate setting. Oh well, not a big deal. Thank you, Terry. I think it is pretty cool too. That's why I was excited to actually show you guys. I really wanted to show this to you tonight. That's why I decided out of the blue to spring it on you for the live stream. So I hope people aren't mad. But there's what it looks like when it's fully open. And if you're counting, you'll see that there are 5 scoops in there, guys. I've got 5 scoops in this array. So this is a 5 scoop array. It would be 7.5 feet tall, starting at the bottom of the scoops to the top. Actually, like tiny bit more than 7.5 because of the scoop supports in between, those dark blue pieces in between. They're a 1/2 inch thick each. Yeah, I think I made them 1/2 inch. But really, what's awesome about this rig is it's going to be permanent, it's going to be sturdy, it's going to hold harmony very rigidly, and from the middle supports here down to the ground is almost 8 feet that I've got there. I have almost 8 feet of space from here down to the ground. So I can mount whatever kind of crazy hardware I want underneath there, trying all different kinds of generators and gearing ratios to go to different generators as necessary. I keep bringing up the fact that I saw the one guy who had a universal joint from an old car coming down from, like, off of his center shaft. He had it coming over at about 45 degrees down to about here, where he then connected in, where I'm wiggling my mouse, to his generator and stuff down here. So that's really cool because you could mount the generator right onto this pole, so you have a nice rigid mounting, and you could come off of it over to this generator. You could have another generator on this pole, and all you do is change that universal joint to that one, and you could test another generator or have a third one over here. The universal joint was pretty freaking neat. It was actually a really cool idea. Super low tech, but a neat idea. The thing I'm excited about is all of the space down here. All of that good space, because I never had that before. In my other model, if you guys remember the white one that I took outside, it was like I had 6 inches, not even, 4 inches of space in there or something. No, maybe it was 6. It was painfully small down there in that bottom area, and it wasn't enough to really work with proper generators. And I didn't know it at the time, but coupling your turbine with a properly sized generator is a bit of science and a bit of art. It's not something that you can just throw together and it's going to work perfect. Your generator spins at a certain RPM range where it's efficient. The turbine spins at a range that it's going to be most efficient in the given wind conditions. So the coupling of those two is very important. And then on top of that, your charge controller plays into that. So lots and lots of things play into this. And having the room and the space down here with a permanent outdoor prototype is going to be key to making some really good, strong headway with figuring the final numbers out and figuring out the performance of harmony, just all of the stuff that goes into this. Sorry, Mom. That was my mom calling. I told her earlier I was going to have to decline because I'd be doing a live stream. Let me tell her quick. Told her she can watch me on YouTube if she wants. Anyway, sorry about that. I knew she was going to be calling. She was trying to get a hold of me earlier. Back to what I was saying. Thank you, Mike. Let me catch up to a few comments here. People are just saying, wow, it's cool, looks fantastic. Do you know if the front guard will cause any wind noise as the wind leaves? No, Mark, at this point, no, because I haven't even built this model yet. And in the white ones that I had, let me pull that up. I'll show you. I'll show you a quick video and actually stop it.
Hey Google.
So in this one, guys, here, you can see the guard on this was a whole 180 degrees. I pretty much had the front guard. It was those, well, it was almost 180 degrees. I'll call it 170 degrees, but it went from the beginning of the gear over all the way to the end of the gear. I don't think it's needed. I don't think it's necessary to have it 180 degrees like that, but I do believe we need something in there. And Mark, with it being 180 degrees C, okay, that was a pretty good amount of space in there. I was thinking it was like 6 inches, maybe it was about 8 inches, but certainly not enough to mount other types of generators in there. It was barely enough to get just that one little pancake generator in there. There was definitely no room to mess around and do other things with it. So this scoop array was, when it was fully opened, was 4 feet wide, 4 feet tall. The new one is going to be 6 feet wide, 7.5 feet tall. And that's really big. Probably, I don't know, maybe it's a little bit larger than I want to end up for a residential size, but, you know, it doesn't matter. I need a starting point. So if bigger is a little bit better because it's easier to work with and gives me more torque, and, you know, that's fine. I can play around with all different kinds of generators then. But in the old one, to answer your question, Mark, that front guard was pretty much 180 degrees. It went from the beginning of the gears all the way to the end of the gears. And the new ones that I'm proposing, you know, I am looking to keep them smaller. If I can get away with just 90 degrees, then that's what I'm going to go with. The whole thing here, when you look at it as it's spinning, when it's fully opened, you don't have anything to worry about with the that gap. So you really don't need a guard if you're just going to stay fully open. But as soon as we start furling, then that guard comes into play. So see that? I keep hitting the wrong thing. My apologies. When it's fully open like it is right now, that guard really isn't going to do much. So that's why I don't want to make it bigger than it needs to be. That's why I'm not just going with a 180 degree guard, because I'm blocking a fair amount of this scoop that's catching the wind. I want to have it as minimal as possible, but still do its job, that once I start furling, like if I would furl a little bit here, maybe we'll furl up just, that's like 80% opened right there. So it's only 20% furled. You'll see, if we get it at, whoa, it's a little bit hard to angle it at the angle I want. There we go. You'll see how that really starts opening up that gap in the middle there. It really begins to open up that gap, and that's the problem. Let me see if I can rotate it just a little bit. There we go. See, without that guard, there's really a very, very large gap in there. I'll take the guard away once, and you'll see what I'm talking about. It's a horrendous gap. If I suppress that front guard. Isn't CAD amazing? Look at that. I just did what would take you 3 hours, 4 hours to remove those front guards. Even if they were just in there with 2 screws, it would take you, well, not 3 or 4 hours to do it then, but it would take you a while to get up there and unscrew each one carefully without breaking things. But see how much it's just opened up so much without that front guard. I think you'd lose a lot of efficiency in here. So that's why originally I thought, as I was designing the tabletop models and everything, those orange and white ones that I had on the dining room table, I thought, oh, I don't need a guard in the front. But I believe I do, because those tabletop models were fixed in an open-only position, 100% open position, the ones that I did the videos on those. And that's why I couldn't really see it. But as soon as I got it into CAD and started spinning it and having it furled a little bit, it becomes very clear immediately that you need to have You need to have something. I'll keep it at this angle so you can see. See how those big gaps keep opening? And I think I'll try it without the front guard just to try it, or we'll do CFD on it as well, but I think you're going to lose a lot of efficiency there by that big gap. So that's why I have the guards on. Thank you, Terry. So Mark, that was my long-winded way of answering your question. I don't know yet, but we'll find out. That's the beauty of getting to play with it. And Terry, yeah, I don't think it needs to be 180, but I think it needs to be probably somewhere close to 90 degrees, and then where exactly we position it, we'll have to play with that. So that's the beauty of what we get to see here with CAD. Some of the other cool things I'll show you. Oh yeah, you can really see it there. I'm furled up like, in this shot, I'm furled up pretty heavily. I'm probably 60% furled at that point. So I'm below the halfway point. Like there's the halfway point of furling. I guess right there is exactly halfway at those two marks. And you can see that massive gap, massive gap that you would get every single rotation, twice per rotation actually, you'd get that huge gap. So if we add that guard back in, put the guard back, and then we look at the scoop pair without moving a thing, now you can imagine with that pull in there, no, I didn't have the pull in the grouping here. Yeah. Well, you can imagine with the pull in there and the furling tube, then that gap is almost completely taken up. Almost. So I believe that's going to be a lot better with that guard. But even if those guards, believe it or not, right now were 180 degrees, they wouldn't do anything more than what they're doing now, because they're already out at the front where, if you can see my mouse, they're extending as far front as they can be. So in fact, if they were continuing around and coming all the way around to the front of the gears, here I'll rotate it a little bit and you see what I mean. If they were coming all the way around to the front, I think the guard would actually hurt more than help by being 180 degrees. So at 90 degrees right now, that wind is able to come into this spot right here and get caught. For that moment as it's spinning, it gets caught. And computational fluid dynamics will help prove that out. But that's why I think a 90-degree guard is going to be best. And then we'll just play with where exactly we would position it. I mean, maybe it could be slightly less than 90, maybe like an 80-degree guard or a 75-degree guard, but something closer to 90, much more so than 180 degrees, to me, looks more correct. All right, so yeah, with that guard in there, now you'll be able to see when it animates again. You'll be able to see just, I haven't changed the angle of this shot at all from what it was when that big gap was there. And you'll see with that guard how much it helps to really close that up. So there's very minimal, you can see very minimal moments where you would have that air being able to get through there. I think that guard really does a nice job of both maximizing the scoop capture, the momentary scoop capture, whatever it would be called, and then giving us a lot of protection for any air that would have gone through the middle there. I was just, sorry, I paused. I was just looking at the way that looked. And with the scoop pair, it's kind of cool too, because if I hide this top one and then do a top-down shot, there's an interesting phenomena that by having the back this like sort of vent opened here, I believe we're also going to get some shuttling of air when you've got the scoops maybe in an 80 degree, or not 80 degree, but in about an 80% open state or 20% furled state. I think you're going to have, as the wind enters the one side here, I think you're going to get wind going in if you can follow my mouse flowing around, because it's going to follow the scoop. When it hits, it's going to flow around, and it's going to shoot out this opening here, right here, like a vent, and then it's actually going to shoot it into the other scoop. So that's why I don't want to make the guard any bigger. In fact, even at that degree, it's starting to block it. So if it were more like that, then it would shoot out of that scoop and into this other scoop. So the wind would come in, shoot through, and come out. So this actually helps to propel this back scoop, the one coming into the wind. It helps to push that scoop through the wind even harder. That phenomena has been noted by computational fluid dynamics and demonstrated in Savonius wind turbines for years and years and years. So we actually get to take advantage of that bit of a helping hand, if you want to call it that, because Harmony exhibits Savonius characteristics with these blade designs. It's both Savonius and Venturi effect fluid turbine kind of combined into one. I think Harmony is amazing, and I can't wait to start proving it to the world. But what I really want to see is when we have wind and we're producing, then I want to play with the furling state, opening it slightly, closing it slightly, playing with that front guard positioning, and see if we can get some really interesting numbers out of Harmony after we see what furling states appear to produce the best power output in given wind speeds. So, if you could duct the wind into the cupping side and increase wind speed. Don, that is what I was just describing. Maybe you were coming in a little late, but I think that's what I was just describing to people, ducting it into the other side there. Hello, Don, by the way. So anyway, guys, that's it in a nutshell. I didn't want to make this really long. We've been already on for over 30 minutes talking. 5 scoop array, about 7.5 feet tall, 6 feet wide. When it's fully open, fully unfurled, I will put it back into a fully open state one more time and show you, for those of you who might have joined late. So there it is, fully opened. And if we get the cross section, there we go, where it's not being obstructed. So this scoop right here at the top and the bottom are about fully, perpendicular to me. It would be, or tangent to me, I guess that would be tangent. These will be from tip to tip about 6 feet across. So 6 feet across there. The poles themselves are mounted on an 8-foot diameter to give it enough room so that as it's spinning, we don't get anything hitting. So you can see it spinning from the top. So nothing will hit. That's fully open. That's as big as it can go, and it's still got plenty of room in there so that it won't hit anything. And then we have plenty of room down below to play with Harmony. I hate this. Gotta make it bigger so it doesn't stop. So I'll have to send in a feature request and ask Onshape to remember your degree for the animate. Anyway, so we have all that room down below to work and mount generator and any type of gearing or pulleys, whatever we want to do in there. So you can see it's got plenty of room, and it should give a lot of rigidity with this frame structure. And like I said, I'll probably put 45-degree supports in here, maybe 8 inches down or something, and have it coming up to about the middle, something like that, just to give me some extra stability for the weight of Harmony, of the turbine scoops, to take care of that extra weight. These gears are going to be, I believe, I'm going to water jet them. So we'll cut the gears out with water jet, and I think water jet will actually be able to give us enough resolution that these gears will be just fine in this. By making it larger, believe it or not, things like water jet now become the perfect choice. I don't have to actually have parts machined for an expensive milling operation. We can just water jet these gears right out of 1-inch aluminum or 1-inch steel, whatever we decide we end up having to make them. I'm going to try aluminum first. I think aluminum will be fine, but we should be able to water jet these gears right out, and that's slick. When you think of that, that really, really, really will cut down on manufacturing costs and everything. We can water jet those gears out, then we can just drill and tap these holes. Well, the water jet can put the pilot holes in, and then we can just tap them. So when you think about how freaking cool this would be to manufacture and get into low volume manufacturing, because we're just initially going to be making enough that we can do the testing we need, and then maybe get a couple out there to some of the early investors who paid enough that wanted to be a beta site. Low volume production where we get a couple of these out, probably a dozen or less, and get these out in people's hands so that they can start testing and validating data and performance and production and everything like that. But by having these gears as large as they are now for this new version, yeah, it's really exciting because we can just water jet those gears, and that's pretty sweet when you think about it. We'll probably still want to broach that keyway just because that's a very delicate thing, and I don't think water jet would give us quite a sharp enough result there if we water jetted that keyway out for the furling gear. I believe that's going to be still a broach process because I didn't want to make that keyway too deep. It is right now a 1/4 inch wide and an 1/8 inch deep into here. Obviously the other 1/8 inch, if I go into the scoop array and I look at it from the top, hide a few parts here, hide the furling tube. Oh, whoops. Hide the main shaft. There we go. Now in the real one, there's not going to be 5 keyways in it. I just do 5 keyways because it gives me in CAD a way to attach each of the scoops onto their own keyway. But there's what my keyway looks like. So I did. Oh, maybe it is only an 1/8 inch deep. I'm sorry. I believe I was saying the wrong thing. Yeah, okay, so that's a 1/16 of an inch in the gear, and then a 1/16 of an inch in the furling tube to give me a total of 1/8 inch deep key by a 1/4 inch wide key. So the keys should be sufficient. The furling gears are going to be taking some torque, definitely, especially in higher winds, they'll be taking torque. But I didn't want to cut away too much of this meat here where I'm moving my mouse to come in a whole other 1/8 inch. That would have brought this keyway down to here, and I didn't want to hurt the integrity of that gear that much by cutting into there with getting a 1/4 inch by 1/4 inch keyway. So I stuck with an 1/8 inch by 1/4 inch keyway and a key. The furling tube, what's kind of cool is if you imagine it being like a PVC pipe, because that's what I made my furling tube out of before, the key does not have to go the entire length. It doesn't have to go the entire length of that furling tube, which would destabilize its integrity. All we need to do is have the key be 2 inches long, at the beginning to the end of the keyway, and then it stops. And then 18 inches away for the upper keyway, it has it. And then that just repeats. So the tube will have all of the rest of the rigidity and the integrity of the rest of the tube being fully intact, and just the small portions where we cut out the keyway are the only places where we disturb the integrity of it. So this furling tube, I think right now, I have it at 1/8 inch, sidewalls. So that's a 1 inch radius, OD, and 1/4 inch ID, which gives you 1/8 inch sidewalls on the furling tube. That should be more than enough if we have, even if the furling tube is made out of aluminum, it should be fine, but I'm probably going to do the furling tube and the main shaft are going to be steel. I think they'll both be steel. Terry, I'll see you tomorrow. Take care. Thank you for joining. Michael, I know you want to test one in Tasmania, so we'll see how we get, with investments and see where we go from there. Don, let me read your thing. Ducting the wind into one side only. No, Don, no. Let's back away from that idea. People have tried to push me into that for a long time. You know, there's all kinds of inventions out there where people are doing big, you know, heck, I've seen people using plywood to duct it into everything. You can't do that without destroying the beauty of what harmony is. When you see harmony rotating and spinning, it's beautiful to look at. And in my opinion, clean energy should be beautiful. It should be something that people want in their front yard or on their roof, around their kids, not something they're having to hide away and put out in the mountains somewhere where they don't want to look at it, and then they have to pay for someone to pipe it back into their house and pay for distribution and all that. Harmony should be beautiful. In fact, I don't even want to have a frame around harmony if it can be helped. Once we get into production, I'd like to start testing on making whatever support tubing and stuff coming up to the center sufficient enough that harmony won't need any frame around it at all. So absolutely not. I'm not going the way of ducting anything into it, because if you try and put ducts around it, you've got to either put the ducting on a big huge swivel or have it permanent, and then, you know, now you're like having to guess where the wind is coming from to duct it in, or you get those ones that I've seen where they have a whole bunch of ducts all around and you can't even see the turbine. Then you've got a big huge industrial piece of equipment in your yard and not something beautiful. Right now, harmony, if that were spinning in my front yard, to me that's beautiful, and I don't want to destroy that. So thank you for the suggestion, but I am absolutely not going in that direction. If you want, I can send you a couple links of people who are looking at doing ducting and playing around with that. I believe they have, I don't know, 4 or 5 different models that I've seen where people are playing with ducting into vertical axis wind turbines. I don't think harmony is going to need it. I truly don't. From what I've seen already with the white model that I had and the performance that I was getting, yes, I didn't have it hooked up to a generator properly. I didn't have good wind conditions. You know, everything about those tests was pretty, I won't say it was pathetic, but it was pretty sad. This attempt is going to be getting a much more substantial turbine, a much more sturdy turbine, and you know, I think preserving the beauty of what harmony is just as important as it being a functional piece of electrical engineering or mechanical engineering product that you have in your front yard. So I'd like to hide the fact that it's really generating electricity for your house with the fact that it's so very beautiful to look at. People don't even think about it generating electricity. What's wrong with more than one key? Nothing. Nothing at all. I could potentially put multiple keys going around it, but I'm looking to disturb or impact that furling tube as little as possible, Mike. So I'm just looking to put, for each scoop pair will have 2 keyways. So in this case, where I've got 1, 2, 3, 4, 5 scoop pairs, then I would have 10 keyways cut into the furling tube. And each keyway is only probably going to be about 2 inches tall by 1/4 inch wide. So, and only an 1/8 inch, no, a 1/16 of an inch deep. So those keyways are going to be as minimally invasive as I can get them. I don't want to get into disturbing the integrity of that furling tube too much, because that furling tube does a lot. It's what holds all of the torque of the turbine blades to hold them in position in whatever furling position they need to be. And Mike, have you seen, I don't know if you know, here was the white one that I had, and you can see it spinning. Let me back it up a little bit. Have you seen, you know, stop me if you've seen this already, but here you can see it actually unfurling as it's spinning. So there it is, the last prototype that I had. It's actually unfurling, and you can see it picking up speed there. That was just in like a 1 mile an hour wind. So, you know, that process is what I want to really be careful of, not messing with that furling tube too much. I want to keep the anything that's disturbing its integrity down to a minimum. And cutting keyways into that furling tube certainly does, disturb that furling tube's integrity. Okay, let me just make sure if anyone else has questions here. Don, I hope that didn't upset you that I was so adamantly opposed to any kind of ducting, but I am absolutely positively opposed to putting any type of ducting around Harmony here. I hope that is okay and not hurting, what you thought of my project, or, if you're like, oh, screw this, man, if he's not doing ducting, I'm not following it anymore. Hopefully there's a lot of upside to Harmony, and you'll come to see that I don't need ducting after all. As for gears, you should test half of them. So quieter is not a problem either. Don, are you aware that I apologize, guys. I've had so many followers for so long. Some of the names are new to me. The furling gears are only going to be moving when Harmony is either furling or unfurling. Okay, and it should only be doing that little tiny bits at a time. Even in prototype mode, where I'm going to run an algorithm that it's constantly going to be seeking and opening up a little or closing up a little, where it's going to be doing that. The only time it's going to be moving these gears, and what you're saying, because they're quieter, if we'd make them helical, that they're quieter. Yes, I know that even helical gears, I think, are actually stronger too, because there's more engagement. But it's moving so minimally, that even if you would go from a fully closed to a fully open state, you're probably only looking at a 30-second operation from fully closed to fully open. So, and certainly it's not going to be sitting there furling and unfurling when it's in production operation at your house. It's going to pretty much sit there at one state for hours and hours on end, and then maybe it'll move 5 degrees to close up a little bit or something 2 hours later, and then it stays in that new position for another 2 hours. So there will be very, very minimal noise coming from those gears, because they're not going to be moving 99.9% of the time. Those gears are going to be stationary. They're only used when Harmony demands that it be opened or closed a little bit or a lot, depending on what's going on. When it asks for those gears to furl or unfurl is the only time those gears are going to be getting used. A lot of people early on in my project were like, they were coming at me, yelling at me and stuff, because I put a plastic piece of PVC tube in this model. I put a PVC tube over top of a steel, like that PVC tube is what I was using as my furling tube, over top of a steel main drive shaft. And people were yelling at me like, there's way too much friction there, dude. You're never gonna, that's gonna burn up in the first, 5 minutes of running, blah, 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 blah. It's all bullcrap, guys. These are people that are armchair critics that don't know what they're talking about, because that furling tube, 99.9% of the time, isn't doing anything. It's just sitting there stationary on the main shaft. The furling tube and the main shaft spin together. Here's another shot of the furling tube as I'm assembling it. That furling tube, the gears, the main shaft, they're all pretty much riding together as Harmony spins. There's the main shaft, and that main shaft and the furling tube are all one unit for most of the time. The only time that the furling tube spins on the main shaft is when it's actively opening or closing. It can be spinning all day long, and as long as the furling tube, as long as Harmony hasn't asked to be opened or closed at all, whatever state it's in, if it's fully open, it'll sit there all day long, and not a single drop of power will go into that furling mechanism if it doesn't need to be open or closed, and that furling tube will be stationary on that shaft. So when it's spinning like this, those two are locked together. Here, I'm being silly. So I'll show you right now. I'm going to lock the furling tube. I'm going to fix it. So right now the furling tube is fixed, so it can't rotate. If I try and close the furling tube, nothing happens other than the whole unit spins. I can't close the furling tube right now. Or furling tube, I'm sorry. I can't close the scoops because I have it locked. So the only thing that Harmony can do right now is spin. And you'll notice, even CAD doesn't lie, with that furling tube locked, it just spins. So, there you go. So Harmony is just sitting there happily spinning. It's doing some weird CAD calculation because it's determining the max that it can spin based on the furling tube or something there. Oh, I know why. I'm sorry. It's fixing the furling tube, literally holding the furling tube still as the main shaft spinning. So, my bad. I can't fix the furling tube. What I could do if I unfixed it. Okay, I know what's going on there in CAD. It's fixing the furling tube in space, not against the main shaft. If I changed the mate feature of the furling tube, if I edit that, I don't think I can because I would have to change this instead of a revolute mate to a fixed mate. And then the furling tube will... Anyway, take my word for it. The furling tube does not spin on the main shaft at all other than when it's opening or closing. Sorry. I probably talked for 10 extra minutes and I didn't need to. My apologies. Yeah, Mike or Mark, I do like it with 5 scoops very much myself. It's really, really kind of cool with the 5 scoops, and maybe it would be even cooler with 6 or 7, but I don't want to get too crazy right now. So, let me fix that. Oops. There we go. I could put bigger values in there, but then it takes forever to do the calculations to even begin spinning, so it's kind of like a trade-off. If I put 5,000 or 6,000 in, then the whole thing sits there and calculates for like 40 seconds before it even starts spinning. So I put 2,000 in, seems to be a pretty good number. But there it is with fully opened. And here I was going to show you with it like halfway closed. It's pretty cool. Like we'll do 50% furled once. Yeah, there's about 50. Right there is about 50% closed. I was looking for the little tiny drill hole down in there. So there's 50% closed right now. It looks badass when it's like beginning to furl. That's what I love about Harmony. I think we're going to find some amazing data here, guys, when we begin getting out there and testing different furling states in given wind speeds. We'll do 3,000. Let it calculate a little longer. But it's really, really awesome when we start getting into the testing of different furling states in given wind speeds. That's what I'm excited to see the results of. Mike, the white one that I had, see there, it's 50% closed right now, or 50% open, whichever way you want to look at it. That to me is just absolutely awesome to think about. Harmony is the only vertical axis wind turbine that has the ability to control its swept area to this degree. You know, I'm sure there's some out there that have like the ability to change the angle of their blades or something, but nobody at all has the ability to just totally close up into a cylinder and get rid of their swept area completely. We have the ability to go from a 3-foot diameter circle or sphere, no, whoops, not sphere, cylinder, 3-foot diameter cylinder to a fully 6-foot opened wind turbine, which is really, really freaking cool. Oh, for maintenance mode, by the way, here's what it would look like in maintenance mode. Like if you were actually doing work on the generator down below and you didn't want any chance of something happening where you could get your fingers pinched or something down in the gearing below or whatever you were doing. It's weird that I can't grab that. I don't know why. It doesn't let me grab it. I have to use these tools. There it is, 100% closed, which is really, really neat. If we look straight on, dead on, it's just a perfect, perfect cylinder. Now I know in real life it's going to have tiny little gaps because, you know, those scoops aren't going to mate absolutely pristine like they do here in CAD, but it's pretty neat to look at. When you really think about how that can close up into a cylinder, and there's your wind turbine in lockdown mode for maintenance, you'd have it furled up 100%, you put a cotter pin or a locking pin through the main shaft to lock it so it can't spin, and then you can do whatever you want to the generator down here. Think of the safety issues. I never ever want these to be so big that they become a menace to look at or for wildlife, but even if they were 300 feet tall, when you think about this, if you could close Harmony up, have it completely closed, and then put a pin in it to lock it, and then do whatever maintenance on it, you know, it would be amazing because you could have, you know, 300 foot tall, and then the place where you're doing work on it could be all the way at the ground because that main shaft could come all the way down to the ground, just all the way straight down to the ground, and then you'd have your generator equipment all on the ground. That's like amazing when you really think about that. There'd be no reason, you know, unless you needed to get up and modify or change something up there. But again, I don't even believe I just said that because I never ever, I don't think that I want to see 300 foot tall Harmony turbines out there. I don't believe that I want to see that. So anyway, my thought is clean energy should be something we don't want to hide away from our houses. We don't want to hide away from society. It should be something beautiful to look at that you'd want right there in your front yard, that your kids and your family can be around it. It's not making any noise that's giving you headaches. It's not, you know, driving you and your neighbors crazy. It's something beautiful to look at and makes power for you at the same time. Here we should get a little bit faster rotation with 2,000 steps and 3,000 degrees of rotation. This should cause it to rotate quicker, which is going to be a little interesting to look at. Slightly faster. Yeah, Don, this should be absolutely no danger to birds. It's a solid spinning mass in front of them. They're going to see it just like they would see a grain silo or your house or an outhouse or any solid structure in front of them. There isn't enough empty dead space that they're going to be like, oh, I can fly through there, and then suddenly they get cut off and hit. There's so much happening in front of them, they're just going to go around it. They're going to see it, and they're going to fly around it because to them it will look like danger, Will Robinson, I need to avoid this. The reason they don't avoid the big, huge 300-foot horizontal wind turbines is they don't even see that blade. It's so far away from them when they're coming through, they don't even see it. And by the time it hits them on the back of the head, they're not looking up when they're flying. They're looking ahead and down at the ground. They're looking straight forward or down. That blade comes and whacks them over down from the top because those blades are moving like 300 miles an hour or something crazy fast. And when it whacks them, that bird never even saw it coming. That's what kills the birds. Harmony, I don't care how big you make the thing. Here I go again, talking about making it huge. But if it was made huge, it would still be a solid object in front of them. It would not be killing wildlife because they would simply fly around it. Yeah, Don, that is the high speed and hurricane areas are going to be amazing. I think once we start getting funding and once we start getting testing, the Philippines contacted me, not the Philippines, but the Peace Corps from the Philippines contacted me a year and a half ago. A rep contacted me and asked me if I would consider licensing it to them for their typhoons. They didn't want to generate electricity with those units. Not that they wouldn't. Maybe they would have some hooked up for that, but they wanted to pump water with them. So they would have the Harmony scoops with their furling capability hooked directly into water pumps and be pumping water with them. Because as long as it's not freezing rain, just normal rain, you could rain on this thing all day long. In fact, it would probably spin even more powerfully with driving rain because, you know, rain is so much more dense and the water hitting it would be so much more dense. So Harmony would just be furled up to whatever degree it needed to be furled up to keep it spinning within a safe RPM range. But really my theory is this sucker would keep right on spinning right through that hurricane or typhoon. And yeah, in those cases, maybe you are going to need a full cage around it, exactly like you see here. You might need these around Harmony in hurricane and typhoon areas. But I don't believe there's any other turbine out there that would be able to hold a candle to what Harmony will be able to do in those high wind situations. And face it, when you have those massively high winds, the power that you'd get from these things, yeah, you could probably generate, you know, I don't even know, like 15, 20,000 watts of power off of a residential size unit if you had a powerful enough generator hooked up to it and the scoops in the main shaft were made out of strong enough materials that it could withstand that kind of torque load to make 20,000 watts. But I mean, God, you imagine the wind power in a hurricane or typhoon. And if the news crews were out there and they're like filming, and we've got 10 Harmony wind turbines out here just massively spinning away, pumping thousands of gallons of water a minute, saving, you know, all these thousands of homes and everything from destruction, that would be absolutely priceless to see that. Absolutely priceless. I think it would be really cool. Yeah, Don, that would suck. 90-degree temperatures, 13 days. I'm sorry that Harmony wasn't there to help you back then, but maybe if we all work together and we get good seed funding here, maybe we can get Harmony out there for the public, you know, in short order. I don't know how quickly that'll be, but we'll see. Yeah, without power, that would suck. Excuse me, I have hiccups. Noctu, how are you? Where are you from, Noctu? Could this work in water, like in a river? Sure, water is a fluid, just like air. It'd be hellishly powerful in water. I think it would be fine, though. You'd have to, you know, make them out of stainless steel or something so you didn't have to deal with rust. And you would probably have a problem with sediment getting into the gearing and stuff like that. That would be an issue that could be a bigger problem than anything. Like with snow and ice is a big enough problem to think about, and I do plan on one day when we get enough funding throwing an engineering team at it and saying, okay guys, solve the problem of snow and ice now. Where do we put resistive heating in Harmony to allow it to melt the snow and ice off the gears and out of the scoops? But there wouldn't be anything you could do to get rid of sediment and silt building up in the gearing and stuff, so that may be a killer. However, here's a thought. You probably wouldn't need to worry about furling up underneath water. You would just find the optimal setting for about the speed that that river flows, because rivers are pretty consistent. I don't know that even when they're running high, like, in flood conditions, that they're running much faster. They're probably still running close to their same speed, because the speed that the river flows would be a direct function of the drop, not the volume of water flowing through. So, given that, Harmony probably wouldn't even need furling capability underwater. You would just set it at whatever optimal furling state for the given speed of water flowing past the areas where you've got them, and you would just set them up in the river that way. So yes, I think it would work just fine, but you'd have to take into account the furling mechanisms would be a problem. So you'd need to negate them and just have it at a fixed furling state for the river. Oh, you're from Minnesota. Okay. 82, 5,000. Sorry, I was late for... So... Oh, I'm like stupid. Ray, you're asking for a moment. I thought you were the same. I didn't notice the name and the name change there. And I was thinking you were Noctu asking the question about the speed for a good result. So Ray, you're a different person. Hello, nice to meet you. The wind speed for a good result is yet to be determined, because if you're just late to the game and coming in, I've got like 100 videos, no joke, of me building this whole system from the beginning of time when I began my project 2 years ago. Here it is. Here's where we started 2 years ago. This little tiny wind turbine prototype was the first one. I put it in my window, and that's blowing just on the breeze coming through the window. There, I'll rewind it so you can see. So it's blowing on the breeze in the window. That was the very first prototype version that I made of Harmony. Then I went to this one, which was, considerably larger. But again, that's blowing in the wind. There's no generator on that. It's just a proof of concept. And then I went to this much larger version, which then I machined everything out. And finally, wait for it. Here it is, Ray. So there it is. That's the largest prototype that I've made to date, up to this point. That's the largest one. So I do have a generator hooked up to it down there, but where I was testing this, the wind is terrible. Absolutely horrible. And the day that I was testing, even though it was supposed to be a good windy day, was not. We only had like up to 5-mile-an-hour winds right there where I was testing that, and it wasn't sufficient. So there is the largest prototype I made to date. The new one that I'm looking to do, this one, Ray, is when it's fully open and fully unfurled, it will be 6 feet wide and 7.5 feet tall, the turbine scoops. So 6 feet wide, 7.5 feet tall would be the swept area. That, my friend, is 45 square feet. And I think when I did the calculations to meters, that's 4.2, we'll call it, 4.2 square meters of surface area or swept area. So it should be a significant amount of power that this new one can produce. I'm thinking 2 kilowatts in like 10-mile-an-hour wind is definitely going to be achievable, but I don't know yet. Until we build it, until we test it, I'm not going to sit here and brag about what it's going to produce when I have absolutely no idea. I'd just be guessing. Calculations show that I should easily be able to get that much wind passing through that area. How much Harmony captures remains to be seen. How efficient it is at capturing that wind passing through there remains to be seen. So that's work yet to be done. What I am talking about doing is a crowdfunding where I go for seed capital to help actually build this prototype that you see on your screen here. These poles are about 16 feet tall. They are about 8 feet on center, so 8 feet in diameter. And that would allow me to have a permanent prototype out front in my front yard for testing. So that's what the seed funding round is going to be for, to help fund this build. So if you want to be a lot more caught up and a lot more on top of where the project's at, watch some of the older videos, and that'll help you along quite a bit. Okay guys, at this point I don't think I have anything new to put out. I just wanted to show the designs to people, get it out there, let you see everything about it. It's pretty exciting to me. Hopefully it's pretty exciting to you. And it would be neat to work on this together as soon as we start getting seed funding. So I am going to put our Patreon link in case anyone wants to help support us before we get the crowdfunding up and running, because that could be a little while. So there's our Patreon link if you'd like to support us right now. Or you can just go to harmonyvawt.com, and there's our landing page. You could even just do a one-time donation if you want to throw a donation in there to PayPal. We accept a donation. The crowdfunding, seed funding round is going to be as soon as I'm able to get it all done, but I'm waiting for the paperwork to come back from the state, and then I have to go through the paperwork at startengine.com or whichever crowdfunding site that I go with. I believe at this point I like what I see with startengine.com, so I do believe I'm going to go with them. Unless something happens that I can't go with them, I think that's who I'm going to go with. So startengine.com should be where you'll be able to finally buy a piece of Harmony turbines. That's it. Anyone have any last minute questions? Fire them off now. Speak now or forever hold your peace. Thank you, Michael. Thank you very much. All right, guys. I'm going to call it a night. Thank you, Don. Yeah, the patents should be arriving. I don't know. They say it takes like 5 to 6 weeks from when the patent office grants everything. So I would expect that I'm going to need to check my mailbox within the next 3 weeks, maybe, and I might find my present in there. I've never received a patent before, so this will be new to me. I guess they just send it to you in the mail. I don't really know. I've never gotten a patent. So we'll see. I'm kind of anxious to see how that works and what they do. But, you know, that's just a piece of paper, really. It's the real journey is beginning now, and the hard work and the everything to make this come to life is just now beginning. Are you leaving, hon?
Yeah.
Okay.
I don't want to be on camera, so
Oh.
stay over here.
You can come be on camera. There's like 20,000 people here.
I'm
You can be like YouTube famous.
Nope,
No?
I'm good.
No, there's only 7.
I'm good. So, thank you, though.
All right, love you.
Love you too. I'll see you tomorrow.
All right, bye-bye.
Bye-bye.
All right, guys, thank you. Have a good night, and I will talk to you soon.